I'm going to be explaining type 1 ternary ionic bonds, also known as polyatomic ions. So for this, I'm going to be explaining the formulas and then the nomenclature. For this, topic, you're going to be using the back of your periodic table on the top left, which has all of your polyatomic ions with their names and their formulas. So, for example, if you're given an example, magnesium hydroxide, you're going to write out their elements, their symbols. So magnesium is Mg, and if you look on the back of your periodic table, you're going to see that hydroxide is represented as OH, and what this is just a mix of hydrogen and oxygen, hence the name. And if you look at the charges, hydroxide will have a charge of -1, and if you look at the front of your periodic table, you'll see that magnesium has a charge of 2+. Now, like before, you're going to be using the cross method, which just means, again, just switching the charges and using it as a subscript. So in this case, it's going to be Mg, and since hydroxide has a charge of -1, you won't be writing anything for magnesium. And the charge on magnesium is going to go to the hydroxide. But because you're saying that there's two elements of hydroxide, you're going to have to put this element in parentheses, and you would write the charge on the outside. The reason for why you're putting it in parentheses is that if it were just without parentheses and putting the 2, what you're saying is that there's one oxygen and 2 hydrogens, which is incorrect. What you're trying to say is that there's 2 hydroxide atoms. So that's why you would write that. And that would be your final answer. Now, for another example, let's take ammonium acetate. Now, if you look on the back of your periodic table, again, you'll see that ammonium is represented by NH4 with a charge of -1. And you will also see that acetate is represented by the formula C2H3O2, and it also has a charge of -1. So as said before, if both of them have the same charge, it's just going to cancel out and they will not have a charge. And so in this case, since you're not adding any subscripts, you're not going to have parentheses for this. So to show this, it'll just be written as NH4, and then next to it C2H3O2. You would only be adding parentheses if you're adding another subscript to the second element, which would mean that there is more than one of that atom, like we showed in the last example. So this would just be your answer for the second one. Now let's move on to the nomenclature. In type 1, just as before, you're going to have your nomenclature written out, not with the transition metals yet, that's type 2, but you're going to be writing it as naming the cation, which is the metal, and then naming the anion, which is the polyatomic ion, and you do not change the ending for this. So, for example, if you're given a formula of MgOH2. You already know that Mg is magnesium, so you're just going to write magnesium. And for the second one, you're going to have to look at your periodic table on the back, and you're going to see that OH, disregarding the subscript that it gives, you're just going to look at OH, and you will see that that is hydroxide. So this would be magnesium hydroxide. And that would be your answer. Now, for another example, you could get a formula of NH4 and CO2. Now, again, if you look on the back of your periodic table, you will see that NH4 is represented for ammonium. So you're going to write ammonium. And the symbol representing CO2 would be sulfate, if you look on the back of your periodic table again. And let me just check that. Correction, this is an S. So, you would just write sulfate for that. And that would be your nomenclature. So to recap, when you're doing the formulas, you write out their charges, cross them. If you need to add a subscript to the second one, make sure you put the second atom in parentheses to show that there's more than one of that atom. And for the nomenclature, you're just looking at the back of your periodic table or the front, depending on which atom it's talking to you about. And that would basically just be it for that.